Assalamu alaikum everyone. Today we are presenting our project on advanced enterprise network implementation. We are a team of three members and now I will start with the introduction. My name is MD Samiul Marjuk and my teammates are Pretom Sarker Dip and Ashiqul Haque. Our main objectives is to build a modern enterprise network that is scalable, efficient, and secure. We aim to use VLAN for segmentation, OSPF for dynamic routing, and NAT for internet connectivity. And finally, test everything using simulation. Traditional networks using static routing are hard to manage and not scalable. So we use modern technologies like OSPF, VLAN, and NAT to solve this. This slide shows our actual project implementation in Cisco Packet Tracer. Here we designed a complete enterprise network including routers, switches, and end devices. It represents how our technology design is implemented physically. SPF is a dynamic routing protocol using shortest path algorithm. It provides fast update and work well for large networks. NAT converts private IP to public IP. There are three types of NATs: static NAT, dynamic NAT, and PAT. PAT is most commonly used. This is our network diagram. It shows how different branches are connected through routers and switches. OSPF is used for dynamic routing between routers, and NAT is configured at the edge router for internet access. Now I would like to hand over my teammate Pretom, who will explain the methodology and implementation part.
Thank you. Now I will explain the methodology and implementation of our project. Methodology includes several steps such as planning, designing, configuring, and testing the network. We first designed the topology, then implemented the configuration, and finally tested the connectivity. Device configuration steps. In this step, we assign IP address to all devices. Each device was configured properly so they can communicate with the network. This slide shows our complete network topology. It includes router, switch, server, and end devices connected together to form the enterprise network. Router configuration. Here we configure routers with IP addresses and enable OSPF routing. This allows configuration between different networks. Configuration screenshot. This screenshot shows how we assign IP address to different devices. All devices are configured properly for communication. OSPF and NAT configuration. In this step, we configure OSPF for dynamic routing and the other hand, NAT for internet access. This ensures proper routing and external connectivity. VLAN configuration. Here we created VLANs to divide the network into smaller segments. This helps to improve performance and manage traffic. Inter-VLAN routing. Inter-VLAN routing allows communication between different VLANs. This ensures that devices in separate segments can still exchange data when needed. That's all from my part. Now I would like to hand over to my teammate for the final part of our presentation.
Now we can see here is OSPF neighbor verification. This slide shows the OSPF neighbor verification. Here we can see that all the routers have successfully formed neighbor relationships. This confirms that the OSPF is working correctly and routing information is being exchanged properly. These are the verification network. We have tested the network using pings and other tools, and the result confirms that the network is functioning properly. This slide shows three important verification. First is the ping test that confirms end-to-end connectivity between devices. Second is OSPF routing table shows dynamically learned routes. Finally, NAT translation entries proof that private IPs are successfully translated into public IPs. In this slide, we present the overall result of our project. The successful implementation of OSPF, NAT, and ACL ensures efficient routing, enhanced security, and improved network performance. Here you can see is a picture of our network, and we have tested the package transfer and the status are successful. These are the simulations. This slide highlights what worked well and the limitations. While OSPF reduced manual work and NAT solved IP address issues, however, the project is simulation based and does not include real hardware changes or redundancy. In conclusion, we successfully designed and implemented an enterprise network using modern technologies like OSPF, VLAN, and NET. These are the references that we use to make our presentation slide. And that was all from our side. Thank you.